This question is about transformers and the power in a transformer related to its efficiency. So we have a transformer, we're told the efficiency is 80%, and we've got 7,000 turns in the primary coil, and we have a secondary coil. So number of turns on the primary, we have 7,000. And then number of turns on the secondary, we have a much lower value. And the number of turns on the secondary is 175. Primary on the transformer, 240 volts. So 240 volts AC, has to be AC, otherwise it wouldn't work. And we're told that the current in the secondary is 8 amps. So you have 8 amp current there. Okay, and then we're asked to work out what the relationships must be. So we're not told what the current is on the primary, but we should be able to work out what the secondary voltage is. So the power on the primary. So the power of the primary is the current in the primary multiplied by the voltage of the primary. And that is equal to 0.8, because of this efficiency, that's 0.8 of the current on the secondary multiplied by the voltage on the secondary. Okay, so then we also have the ratio of the voltages are independent of what ends up happening with the current. So the ratio of the voltages will remain constant. So we need to work out what the voltage would be on the secondary, and that will allow us to solve everything else. So the ratio of the turns gives us the ratio of the voltages. So we have 7,000 to 175. And therefore we need to divide 240 by 7,000 multiplied by 175 to get that to the same ratio. So 240 divided by 7,000 multiplied by 175, and we should get a much lower voltage than we do, and we get 6 volts. So we're looking at 6 volts here. So that would mean that we would have 48 watts present on the secondary, and that 48 watts should correspond to that's 0.8 of the power at the primary. Now I know that from my times tables, I know that 60 watts will give me 0.8 of that, but I can divide 48 by 0.8. So 48 divided by 0.8 gives me 60 watts at the primary. So my power at the primary is 60 watts, power at the secondary is 48 watts. So I've got those values. Now I'm looking at which primary current gives me a power of 60 watts. Well, the primary current that gives me a power of 60 watts, I can use this voltage and this power. The voltage is 240, so power divided by voltage. Power divided by voltage, so 60 divided by 240 gives me a quarter, so 0.25, so that's 250 milliamps. So it must be 250 milliamps, and the secondary voltage is 6 volts. So the only one that matches that is A. If you look at C and D are as if it's a step-up transformer, so they are clearly wrong. So the only possible alternative would be B, but then the powers don't work. The powers give you the ratio being incorrect.